In episode 27, titled Resampling Methods, Bootstrapping for Confidence Without New Data, the goal is to estimate uncertainty using the data you already have as a stand-in for the larger population you wish you could observe. Many DataX questions revolve around how confident you should be in an estimate when collecting more data is expensive, slow, or impossible. Bootstrapping provides a disciplined way to approximate uncertainty without inventing new assumptions or pretending the data is more certain than it really is. This episode treats bootstrapping as a reasoning framework, not a coding trick, because the exam is testing whether you understand why it works and when it should be used. When you can explain bootstrapping in plain language, you can justify confidence intervals, stability claims, and model comparisons even when classical formulas feel shaky. The focus here is on intuition, limitations, and communication, because those are the points where learners most often stumble. Before we continue, a quick note. This audio course is a companion to the DataX books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series.
Bootstrapping is best defined as resampling with replacement from the observed dataset, treating that dataset as a proxy for the unknown population. Each bootstrap sample is created by drawing observations from the original data, allowing repeats, until the resampled dataset is the same size as the original.
Because sampling is done with replacement, some observations appear multiple times in a resample, while others may not appear at all.
This process mimics the idea of drawing repeated samples from the population, even though you only have one dataset.
The exam does not care about the mechanics of indexing or random number generation. It cares that you understand the logic of using the observed data as a stand-in for the population. When you see bootstrapping described as reusing your data to learn about uncertainty, you are reading it correctly. DataX rewards this conceptual clarity because it prevents you from treating bootstrap results as magic or as guaranteed truth.
The reason bootstrapping works is that it approximates the sampling distribution of an estimator, which is the distribution you would see if you could repeatedly sample from the true population.
For many statistics, such as means, medians, error metrics, or model performance measures, what matters is not just the estimate itself, but how it would vary across repeated samples. Bootstrapping creates many pseudo-samples from the observed data and recomputes the statistic each time, producing an empirical distribution of that statistic. That empirical distribution acts as a stand-in for the unknown sampling distribution, letting you reason about variability, bias, and uncertainty. The exam often tests whether you know that bootstrapping is about estimator variability, not about improving the estimate itself.
When you can say that bootstrapping helps you understand how much an estimate might change if you had different data, you are aligned with the intended meaning.
DataX rewards this because it connects uncertainty estimation to a concrete, repeatable process. Bootstrap intervals are especially useful when assumptions behind closed-form formulas are weak or questionable, which is a common real-world condition reflected in exam scenarios. Classical confidence intervals often rely on assumptions like normality, constant variance, or large sample size, and those assumptions may not hold for skewed data, heavy tails, or complex metrics. In those cases, a bootstrap percentile interval can provide a more realistic picture of uncertainty by relying on the observed data's shape rather than on an assumed distribution.
The exam may describe metrics like median, area under the curve, or error rates under skew, and the correct response often involves recognizing that formula-based intervals are fragile.
Bootstrapping offers a way to estimate uncertainty without forcing symmetry or thin tails onto the data. This does not mean bootstrap intervals are perfect, but they are often more defensible when data behavior is messy.
DataX rewards choosing bootstrap intervals in these scenarios because it shows you adapt uncertainty estimation to data conditions. Choosing what statistic to bootstrap is a deliberate decision, and the exam expects you to recognize that many statistics beyond the mean can be bootstrapped naturally. Common choices include the mean, median, classification metrics like area under the curve, and error measures like root mean squared error, because all of these are computed from data in a repeatable way. The key is that the statistic must be computable on a resampled dataset in the same way it is computed on the original dataset. The exam may ask how to assess uncertainty around a metric that does not have a simple formula-based interval, and bootstrapping that metric is often the correct answer. This also applies to feature importance measures, model coefficients, and performance gaps between models, as long as the statistic is well defined on each resample. DataX rewards recognizing that bootstrapping is flexible because it expands your toolkit beyond narrow textbook cases. When you can say, "We would resample and recompute this statistic," you are applying the method correctly. Bootstrapping does have limits, and the exam expects you to recognize those limits, rather than treating resampling as universally safe. If data points are strongly dependent, such as time series observations, repeated measures from the same entity, or clustered samples, naive bootstrapping can break the structure that matters. Resampling individual points independently can destroy correlations and produce overly optimistic uncertainty estimates. Bootstrapping also struggles with extremely small datasets, where resampling mostly repeats the same few observations and provides little new information about variability. In those cases, the bootstrap distribution may look artificially tight or may reflect artifacts of the small sample rather than real uncertainty. The exam may describe dependence or tiny sample sizes and ask what concern applies, and recognizing bootstrap limitations is often the correct response. DataX rewards this caution because it reflects experienced judgment about when a method's assumptions are violated. Bootstrapping is powerful, but it is not a substitute for thoughtful design and sufficient data. It is also important to distinguish bootstrapping from cross-validation because the exam often contrasts uncertainty estimation with performance estimation. Bootstrapping is primarily about understanding variability and confidence around an estimate, while cross-validation is primarily about estimating out-of-sample performance and generalization. Cross-validation repeatedly splits data into training and validation sets to assess how performance changes across splits, which addresses model selection and overfitting concerns. Bootstrapping repeatedly resamples data to approximate the sampling distribution of a statistic, which addresses uncertainty in that statistic. The two ideas are related but serve different purposes, and confusing them can lead to incorrect conclusions. The exam may ask which method is appropriate for estimating confidence versus which is appropriate for estimating performance, and the correct answer depends on that distinction. DataX rewards knowing when to use each because it shows you understand the role each plays in the modeling lifecycle.
Interpreting bootstrap results relies heavily on percentiles and confidence bounds because the bootstrap output is a distribution of the statistic rather than a single value. A common approach is to take percentiles of the bootstrap distribution, such as the lower and upper bounds of a 95% interval, to summarize uncertainty. These bounds tell you the range of values the statistic might plausibly take under repeated sampling, given the observed data. The exam often expects you to interpret these bounds as uncertainty, not as guarantees, and to avoid claiming that the true value lies in the interval with absolute certainty. Bootstrap intervals are descriptive of variability under the resampling scheme, and they should be communicated as such. DataX rewards percentile-based interpretation because it aligns with earlier themes about uncertainty, tails, and robust summaries. When you can explain what the bootstrap distribution says about variability, you can answer confidence questions accurately.
A critical integrity rule is to avoid leaking test data into the bootstrap process in ways that inflate confidence, because the exam frequently tests evaluation discipline. If you are assessing uncertainty of a performance metric, you should bootstrap within the appropriate evaluation set, not across training and test boundaries that would contaminate results.
Bootstrapping test data repeatedly and reporting tight intervals can give a false sense of certainty if the test set itself was influenced by earlier tuning decisions.
The exam may describe a team that repeatedly reuses evaluation data to justify confidence, and the correct concern is leakage and overconfidence. Proper use of bootstrapping respects the separation between model selection, evaluation, and uncertainty reporting. DataX rewards recognizing this because it reflects the same evaluation integrity principles you have seen in cross-validation and threshold selection. When you protect the evaluation boundary, your uncertainty estimates remain meaningful. Bootstrapping is also valuable for reasoning about model stability and feature importance confidence, which the exam may frame as interpretability or reliability concerns. By resampling data and refitting a model or recomputing feature importance, you can see how sensitive those results are to small changes in the data. If a feature appears important in some resamples but not in others, that instability suggests the importance claim is fragile. Similarly, if model performance varies widely across Bootstrap resamples, that suggests the model is sensitive to sampling variation and may not generalize reliably. The exam may describe conflicting results or unstable rankings and ask what method would reveal that instability, and bootstrapping is often the correct conceptual answer. DataX rewards this because it ties uncertainty estimation to interpretability and trust, not just to numeric intervals. When you can say that bootstrapping reveals how stable conclusions are, you are applying it at the right level. One powerful use of bootstrapping is explaining why an apparent model improvement may be noise rather than a real gain, which is a subtle exam concept. If two models differ slightly in performance, the observed difference could be due to sampling variation rather than to a true improvement. By bootstrapping the performance difference, you can see whether the distribution of differences is consistently positive or whether it straddles zero. If the bootstrap distribution overlaps zero substantially, that suggests the improvement is not robust and may disappear with new data. The exam often tests whether you can resist declaring victory based on a single score and instead assess whether the improvement is reliable. Bootstrapping provides a principled way to make that assessment without collecting new data. DataX rewards this reasoning because it reflects mature skepticism and avoids overfitting-driven decisions. Communicating bootstrap results correctly means emphasizing ranges and uncertainty rather than presenting a single fixed estimate as truth. A bootstrap interval tells stakeholders how variable the estimate might be, not that the estimate is guaranteed to fall in that range in the future. Clear communication includes stating what was resampled, what statistic was recomputed, and what the resulting interval represents in terms of variability. The exam may ask how to present results responsibly, and the best answer often involves describing uncertainty bounds and their implications for decision confidence. This communication style aligns with earlier episodes about simulation, confidence intervals, and tail risk, reinforcing the idea that uncertainty should be visible rather than hidden. DataX rewards this because it values transparency and defensible decision-making. When you describe bootstrap results as, "This is the range we might expect under repeated sampling," you are communicating appropriately. A simple anchor that keeps bootstrap thinking organized is to remember resample, recompute, repeat, then summarize distribution, because that captures the entire method in one phrase. You resample the data with replacement, recompute the statistic of interest on each resample, repeat the process many times, and then summarize the resulting distribution with percentiles or other bounds. This anchor also helps you distinguish bootstrapping from other resampling ideas because it emphasizes resampling the data itself rather than splitting it for performance testing. Under exam pressure, this anchor gives you a reliable checklist to decide whether bootstrapping applies and how it would be used.
It also keeps you from overcomplicating the explanation, because the exam does not require implementation detail. DataX rewards this clarity because it demonstrates understanding rather than rote memorization. To conclude episode 27, pick one metric and then explain how bootstrapping would assess it, because that exercise shows you can apply the method to a concrete case. Choose a metric like the median latency, area under the curve, or root mean squared error, and describe resampling the observed data with replacement many times. Then describe recomputing the metric on each resample to build a distribution of that metric under repeated sampling. Next, describe summarizing that distribution with percentiles to form a confidence interval that reflects variability rather than certainty. Add the caution that the result depends on the quality and independence of the original data, and that it should be communicated as an estimate of uncertainty, not as a guarantee. If you can narrate that clearly, you will handle DataX questions about bootstrapping with calm confidence and sound professional judgment.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.